All right. Hello, young ladies and young men who have not finished the Momentum Lab Practical. I'm going to try my best to do this between 10 and 15 minutes. It took us 3 days in class, right? But let me try to help you out here. It is not my intention to give you answers. We did give answers. Students suggested lots of good work during class. I would encourage you to watch that recording. But for grade purposes and to assist you, I thought I'd make this video. Alright, well, this week is Kinetic and Potential Energy Week. It is today, it happens to be February 7th. So right here in the middle of Physics 1 on the content page. First thing you need to do is scroll down to the Momentum Lab Practical. So over here on the left, and click on that, January 21st through the 25th. Right, that Monday was Martin Luther King Day. And that Tuesday, we began the lab practical. You click here to access the simulation. A new tab will open up, and the lab will open. Right, and then down below is a Word document, so I'm going to click on that. You'll want to download this, take notes on it, maybe print it and take notes on it as we go. Let me say this a couple times. This document will not be turned in. It will not be turned in. It's for you to take notes and think about things so that you can take the quiz on Friday, which I will show you at the end. Alright, well, let's begin. Momentum Lab Practical Assessment. It is a test grade. Okay, it is a test grade. There are two parts. Part 1 is elastic collisions, and Part 2 is inelastic collisions. We're going to run 3 different cases in elastic, and really we can only run one with this lab for inelastic. I'm about to show you all this, but there's the lab online. That's what it will look like, as you'll see. Once you open it up, it tells you change the vectors to be momentum vectors only. They are yellow, so I'm going to show you that. All right. We're going to show values at the bottom so you can see all the numbers you need. Do this several times, I guess. We're going to run these labs a couple times. You may want to come back and run them multiple times just to see the numbers. All right, part 1, case 1, make the mass of the balls the same. So let's get started so we can answer questions 1 through 4. So top left, I'm going to click off velocity. Notice the green vector disappears. And click on momentum vector and the yellow one appears. You can also move this down, the whole thing. It's helpful later. Bottom left hand corner, it says more data. Click on more data. And now we have position, velocity, and momentum as well. We're not going to spend any time talking about position, and you probably should not talk about it in your essays, just so you know. Mass, velocity, momentum, and change of momentum, conservation of momentum are things you should think about and write about on these essays that we will get to. Well, case 1 told us to make these the same, so I'm just going to go ahead and make them 1. So red is 1 kilogram and green is 1 kilogram. As we get started, as I push play, it's already in motion. Red is 1 kilogram, going 1 meter per second. 1 times 1 is 1, so its total momentum is 1 kilogram meter per second. Green is currently stopped, and so 1 times 0 is 0, right? The total momentum before the collision is 1. 1 plus 0 is 1. So let's go ahead and play. Let's see, red stops and green takes off. Notice the size of the yellow vector for momentum. It's the same before and after. Over here to the right in the blue box again, the total momentum before the collision is 1. And not surprisingly, because of the conservation of momentum, the total momentum afterwards is also 1. All of the momentum gets transferred from 1 to 2. You can play with other numbers. Excuse me. Red's momentum vector before the collision is shorter than, equal to, longer than green's momentum vector after the collision. We just talked about that. Since green bounces off red, this must be an inelastic, elastic, or explosion collision. So you can review your definitions. Please remember what part of the lab you're doing. 3. Red transfers none, little, most, all of its momentum to green during the collision. So red was going. What happened to red? What happened to green? Question 4. Why does red transfer all its momentum to green? Back up your answers with information from the simulation. Write at least 2 sentences. I can't write on this, I wish I could, but please include the words mass because that's what we changed, mass. We looked at velocity. We looked at momentum. We looked at the momentum before and the momentum after, so the conservation momentum. Those are the key words for question 4. Let me point out, it says 4 points, but this, as it lists, and it's on the quiz, is just a 33-point assignment. To make it 100 points, we have to multiply by more than 3. So this is actually a 12-point essay. Each of them are. These essays make up 60 points out of 100. Please take your time, write a couple sentences, watch the recordings because students really helped out with that. All right, case 2. Now make red much heavier than green. And you can see we've got 3 questions again and an essay. So I'm going down here to the bottom. I'm going to make red 3 kilograms, and I'll just go ahead and keep green at 1 kilogram. Restart it. Notice you can move these away from each other so you can see the collision better. With mass of red being so much, its momentum vector is huge, right? 3 kilograms times 1 meter per second is 3 kilograms meters per second. Notice the total momentum before the collision is 3. 3 plus 0 is 3. Let's play it. Notice red keeps going, green keeps going, like a semi-truck hitting a small car. That semi-truck's going to keep rolling, right? Notice its speed slowed down to 0.5, half of it, and green was going nothing, and all of a sudden it sped up a lot. It's going 1.5. 3 times 0.50 is 1.50. 1 times 1.50 is 1.50, so we notice we have the momentum. 1.50 plus 1.50 is 3. The momentum before, the total momentum before was 3 kilograms meters per second, and afterwards is 3 kilograms meters per second. Watch those numbers. Number 5. Excuse me. Red sped up, slowed down, kept the same velocity during the collision because it transferred some momentum to green. Man, when we get to the essay, you should think about this sentence, right? Well, what happened to red, right? This massive semi-truck hitting a small car. What happened? Look at the momentum vector. 6. Green sped up during the collision as it lost momentum, gained momentum, maintained a constant momentum. Look at that momentum vector. Look at those numbers. 7. After the collision, both green and red stopped as they have lost all momentum. B. Red stopped and green moved to the right. C. Red bounced off green and went to the left. Green moved to the right. D. Both green and red moved to the right. These are all, number 7 here is interesting, all 4 possibilities. 3 of them are elastic, 1 of them is inelastic. You'll see all 4 things throughout this lab. That should help you with the essays. What happened in this one? 8. Again, it's worth 12 points. Only some of red's momentum was transferred to green. Did that not just answer some questions? Why did this occur? Back up your answers with information from the simulation. Write at least 2 sentences. You're not going to get full credit for 1 sentence. You're not going to get full credit for 2 fragments. All right, again, we changed their masses. You should refer to that. We looked at their velocities. We looked at their momentums. We looked at total momentum before and total momentum after. We talked about, I just spoke about the conservation of momentum. Please get some of those ideas in 2 sentences. And again, some great examples from other students that week that we did this. Case 3 of Part 1. Now make red much lighter than green. Again, we have 3 questions and an essay. Let's go ahead and make red 1.0, just trying to keep some numbers easy. And let's put green up at 4.0 kilograms. Right? 1 times 1 is 1, right? Mass times velocity equals momentum. Green is stopped. 4 times 0 is 0. Notice a small vector here. So that's different. 1 times negative 0.60 is negative 0.60 kilograms meters per second. 4 times 0.4 is 1.60, right? 4 times 4 is 16. Move over a decimal, so 1.60. Right? Watch the momentum vector and the numbers, the movement of both of them. The total momentum before is 1. Conservation of momentum, what must be true? Negative 0.60 plus 1.60 equals 1. Conservation of momentum, I know it's a computer program, is always maintained. Why negative? Well, notice what happened here. This continues to the right, and this reverses and goes to the left. Remember here in physics, that negative often means direction. 9. Use the underlined words to find the true statement about the collision. Did green speed up or did it slow down? So we can take 2 of these away right away. Did it gain momentum or lose momentum? Well, if it sped up, which one has to happen? P equals mv. Momentum equals mass times velocity. Since green gained momentum, it just answered question 9. Red had to have gained, lost, or kept the same amount of momentum because you cannot create or destroy momentum. So what happened? Look at the numbers and look at the size of the momentum vector. 11. Since green was so much heavier or lighter. Well, we did that from the beginning, right? So weight and mass are related through gravity. So which green is either heavier or lighter and harder to move? Well, harder to move is a great hint, isn't it? It caused red to bounce back to the left, giving red a negative or positive momentum. So bounce back. That negative and positive, again, is important with right and left. Number 12. So it's another essay question. Number 12 might help you with the other 2. I've said them, but here they are written. Tell me one thing you discovered by adjusting the speeds and masses. Be specific and use words like velocity, momentum, mass, increase, decrease, etc. This one does not say 2 sentences, but you should be comfortable now with 2 or more sentences, especially for this one. Use the words because we kept changing them. Mass, and whether we increased it or decreased it. Velocity, whoops, what happened to it? I can't just get it. What happened to the velocity? Did it increase or decrease, right? Momentum, total momentum, change of momentum. So those are 3 cases. Here's part 2, inelastic. So I'm going to switch elastic to inelastic. I have 4 questions this time and then 2 final essays. I'll restart it. It does not matter because it's inelastic which masses you choose. So I'm just going to do 2 and 2. 2 times 1 is 2. 2 times 0 is 0. Total momentum is 2. Let me run it. Oh wait, I forgot. Over here to the right, I'm changing elastic to inelastic. So elastic to inelastic. Well, it's inelastic, so they're going to stick and go together. 2 times 0.5 is 1. 2 times 0.5 is 1. 1 plus 1 is 2. 2 kilogram meters per second before, 2 kilogram meters per second afterwards. All right, let's make them different masses. So 1 times 1 is 1. The total momentum before is still 1 since I've kept that mass at 1. It's inelastic, so they're going to stick. Notice going pretty fast, and that red slowed down a lot to 0.25. green, of course, picked up a little bit of velocity because it was sitting still, and they're together. 1 times 0.25 is 0.25. 3 times 0.25 is 0.75. 0.25 plus 0.75 equals 1. The total momentum before and the total momentum after are the same. True or false? When red and green collide, they stick together. Well, it's an inelastic collision, and you saw what happened. 14. The velocity of red and green after the collision is larger, smaller, equal than the velocity that the red started off with. So red and green together, compare it to red alone. Red's only 1 kilogram. And with the collision, with the semi-truck colliding with the small car and connecting to each other, what happened to the mass? Or what happened to the velocity? So look at that. Look at those numbers. Right, 15. The velocity after the collision was less because the mass has which? So 14 and 15 go together. 16. Oh gosh, you should know this. The momentum before the collision was less than, more than, equal to the momentum after the collision. Conservation of momentum. Right, 2 final essays, and I'm just saying it again. These are really worth 12 points once all is said and done. Okay, the multiple choice is 1 point, and these are 4 points, but you multiply all that by 3. All right, 17 is deceptively simple. 2 sentences. How are elastic and inelastic collisions different? Well, you could focus on the definition of the word elastic and the definition of the word inelastic, and that would be fine. Do that in 1 sentence. In your second sentence, how are they similar? Well, let me just refer you to question 16 again and several other questions, right? Conservation of momentum, the total momentum before and the total momentum after. What is true? You could focus there on 2 sentences. You may write more than 2 sentences. 18, our final question. Give an example of a collision in real life. Use the law of conservation of energy to describe the transfer of momentum. Be sure and discuss the momentum before and the collision and after the collision occurs. Forgive me. You will need at least 3 sentences to thoroughly answer this question to get those full points. All right. My fat-tailed leopard gecko marches across its green astroturf on its way to eat one of the crickets. Its feet are colliding with the green astroturf. Its weight, its mass, and velocity are hitting that, bending the green astroturf. That's a little collision. Its tongue sticking out and grabbing that poor little grasshopper is a collision. I think sometimes we think about collisions in real life, we think car accidents. Anytime 2 things collide, when your butt hits the chair you're sitting on, that is a collision. Your body's mass and velocity sets down. What will happen during the momentum? Momentum must be conserved. Is your chair strong enough? All right. Good luck on this. We did this actually quickly when you compare what we did that week. All right. So very good. Thank you for your work today. Get this into me as soon as possible. Thank you.